All right, let's continue with graphing polynomials applications, aka word problems. Number 1, all about landscapes. Jalen uses a 4th degree polynomial to describe the shape of 2 hills in the background of a video game that he is helping to write. The graph of the polynomial is shown below. Estimate the x-coordinates at which the relative maxima and relative minima occur. All right, so it's important to remember that relative maxima are the top of the hills. So the top of the hill would be right about here and right about here. So those would be our relative maxima. Relative minima are the bottom of the valleys. So we really only have one bottom of the valley, and it's right there. Now our goal is to estimate the x-coordinates at which all of these points occur. So what we would want to do is try to figure out where does this value cross approximately, where does this value cross the x-axis approximately, and where does this value cross the x-axis approximately. So our first point right here, it's about at -4. So if you said your relative maxima was at x equals -4, or really it's like -3.7-ish, right? So anywhere about there would be approximately right, all right? But let's just round it to x equals -4. So that's one of our relative maxima. And then another relative maxima would be at this point right here, and that's about halfway between 4 and 5. So we're going to say that value is at x equals 4.5. Now these are going to be our relative maxima, so we would say maximums are at x equals -4, 4.5. And then our relative minima is this point right here, and that's just at x equals 0. So relative minima is x equals 0. And there's our solutions. All right, number 2, we're dealing with consecutive numbers. Ms. Sanchez asks her students to write expressions to represent 5 consecutive integers. One solution is x minus 2, x minus 1, x plus 1, x plus 2. All right, so remember, consecutive numbers are numbers that just go in order. So for example, 1, 2, 3, 4, and 5. Those are consecutive numbers. So in this example, if x was 3, right, x minus 1 is 2, x minus 2 is 1, x plus 1 is 4, x plus 2 is 5. All right, so these 5 expressions can represent 5 consecutive integers. And this is just an example, all right? This is not the numbers we're looking for right now. So the product of these 5 consecutive integers is given by the 5th degree polynomial, f of x equals x to the 5th minus 5x to the 3rd plus 4x. Part A is asking for what values of x is f of x equal 0. So how we would solve this is what we're doing is we're looking for what values of x does our function equal 0. So what we want to do is we want to set all of our factors, each of our factors, all 5 factors here, and this is x plus 2, equal to 0, right? So we would say x minus 2 equals 0, x minus 1 equals 0, x equals 0, x plus 1 equals 0, and x plus 2 equals 0. All right, because each factor is a part of the function, right? These are the factors of each of the function. So what we're essentially doing is saying if we set this function equal to 0, how we would do it, how we would solve for x is just by setting every factor equal to 0. So add 2 to both sides here, x equals 2, add 1 to both sides, x equals 1, here x equals 0, subtract 1, x equals -1, subtract 2, x equals -2. All right, so when our function equals 0, our values of x, we would say, not f, we would say x equals, and our solutions would be -2, -1, 0, 1, and 2. And that would be our final answer. All right, now part B is asking us to sketch the graph. So to sketch the graph, we're sketching our polynomial, the first thing we would want to do is graph all of these x values, because all of these solutions are zeros, or they're points where our graph crosses the x-axis. So we know it's going to cross at -2, -1, 0, 1, and 2. Oops. And 2. So these are all values that it's going to cross. And you know what? To make this a little easier to see, what I'm going to do is I'm going to change the values on our axis, right? So we're going to make every 2 boxes -1, then every 2 boxes equals 1 unit, all right? So that it's easier to see our graph here. So let's start by doing that, okay? And we know that each point is going to cross the x-axis. Sorry, I had to pause for the bell. Each point is going to cross the x-axis at these points, because those are all of our roots or solutions. But we need to get an idea of what direction it's going and what our end behavior looks like. So what we can do is we know that our original function is this right here, right? So we know it's a 5th degree polynomial, so that tells us it's going to be odd. So that means end behavior is going to either look like this or like this, right? And it's going to look like this if it's positive, and it's going to look like this if it's negative. So we know that our graph is positive, so it's going to look like that. So we know that the end behavior is going to look like that there and that there, right? That's the ends of our graph and what they're going to look like. But now we need to know what it's going to look like in between. So what we want to do is just figure out what are those in between points, all right? So we're going to make a table, and we want to know exactly how high and how low do our hills and valleys go. So we want to know, what does -1.5 look like? What does -0.5 look like? What does 0.5 look like? And what does 1.5 look like? So what we would do is we would plug -1.5 into our original function, in for x, and when we do that, -1.5 is going to give us approximately 3.3. All right, I already did the math for you guys, but you can use your calculator to figure that out as well. Okay, if we plug -0.5 in for x, we're going to get -1.4. If we plug 0.5 in, we would get positive 1.4. And if we plugged 1.5, we would get -3.3. All right, so this is just going to tell us how high and how low our hills and valleys go. So we're going to graph these points on our graph. -1.5, 3.3 would be about right there. -0.5, -1.4 would be right about there. 0.5, 1.4 would be right about there. And then 1.5, -3.3 would be right about there. So that tells us how high our hills and valleys go. So we want to continue to go up to there, down to there, up to there, down to there, and fill in our graph. All right, and that's just approximately, right? We're just getting an idea of what the graph looks like. And there we go. So now we graphed y equals f of x. All right, and that concludes our application section of this video notes. Please look to the board to see what to do next, and I hope that you have a great day. Bye.